Yes, we are having the solid state lasers. So I'm going to just brief you about the laser techniques. So it's an acronym, or means it's a kind of abbreviation which stands for light amplification by stimulated emission of radiation. It's a coherent. Coherent means எல்லா வேவ்லென்த்தும் வந்து கூட சேர்ந்து இருக்கும். ஒரு மோனோ monochromatic அந்த மாதிரி சொல்லலாம். It's coherent means they are all in line with each other, and there are not different frequencies and different wavelengths. So it's a focused beam. So when you have a certain focus, you see in focus lamps also. Ordinary light spreads light everywhere, right? So if you take this as ordinary bulb, it spreads light everywhere, and you don't have any. It's not a monochromatic light, it's just everywhere. But if you have a laser lamp, or if you have a focus lamp, it directly focuses light on a particular direction. So you have to move it, and it's of particular frequency. So it's a focused beam of photons. Coherent and context means that it is all one wavelength. Okay, so it will be only one wavelength. So 350 nanometers means only 350. So no other thing. But here it will have everything. Like ordinary light which showers on us in many wavelengths, right? So that gives it a kind of power. How are they produced? Light is emitted from a tiny packet called quanta. So we know very well how light is produced. Each photon has a characteristic frequency and energy property to its frequency according to equation E equal to h nu. So three basic ways of photons and atoms interact. They are tracked by absorption, emission, and emulsion. Light amplification by simulated emission of radiations. We know light has to be absorbed and it has to be emitted. So how emitted is a very important aspect. Now, the common components of laser, you don't have to, there is no requirement for you to understand, I remember all this, but just in case, you'll require it when somewhere in for some examinations, I'm just highlighting that. The active medium may be solid crystals such as ruby, neodymium, and yttrium liquid, the rare earths. Okay, some gases like CO2, some helium, neon, and some conductors such as gallium arsenide, they are used in the lasers. So that is the active medium through which everything is happening. So and then you have to excite. Unless you excite it, we are going to see how excitation is bringing about the change in the, that is the emission pattern, and the change in population of ground state and the excited state. And then you have a reflection mirror, so which reflects essentially 100% of the laser and partially transmits a mirror. A mirror which represents 100% of the laser light. So this you don't don't bother. And here are the characteristic of application. What is the main characteristic of application? It has got a high power of penetration, and it is even capable of cutting. It's a multi-photon process, improves signal high scattering intensity, and used in nonlinear spectroscopy, improves sensitivity as well as the Raman scattering. And if you use monochromatic light, its high resolution state is for spectroscopy and isotopic separation. Collimated beam, it's using a collimator. You can just select a particular path length and then transmit it. It's used where you need sensitivity. Laser sensors are there. For example, in the optical mouse that we have nowadays, optical mouse, it is used. So it uses the shades. Earlier you used to have mechanical mouse, and then we used to have the mouse pad with so many different light depths. But now you place mouse on any surface, it's capable of sensing the difference in the textures of that, and is used as a mouse. Is collimated beam is used in the present day optical mouses. So coherent means, again I told you, it is used in cars, and pulsed means, the precision timing acquisition, and used in several things, and we are going to see the application later. So different types of lasers are given here. So in gas you have the argon, krypton, helium, and neon. All the noble gases are being used there. And then in solid state you have got ruby, and it's a mineral and it's a very precious material. And then you have neodymium YAG laser. Metal vapor is also there, copper and solid. Excimer is there, argon and fluoride, and even use some organic dyes and diodes are being used, different types of lasers. But for you, you have only solid state laser in the syllabus. So let us see what the solid state laser is all about. It's a laser that uses a gain medium and that is solid rather than a liquid such as a dye laser or a gas laser. So it uses a solid medium. That's what you have to say. Semiconductor based lasers are available in also the solid state but are generally considered as a separate class from solid state lasers. Usually semiconductors are also called like that, but they have got a separate classification into that. The active medium of solid state laser consists of a glass crystalline host. Host means it is it's opposite of guest. Guest, okay, opposite of guest, and that is it is capable of giving out all that. While a guest is used, a host gives. Okay, so a dopant and I mean is material to which is added a dopant in, such as neodymium, chromium, erbium, thulium, and ytterbium. So again, these are the lanthanides that we have in our periodic table. So most of the common dopants are rare earth elements because the excited states of such ions are not strongly coupled with the thermal vibrations of the crystal lattice. Remember, this is a very important point, and you have to remember this. Why we are using solid state laser? The excited states of such ions are not strongly coupled with the thermal vibrations of their crystal lattice. What will happen if they couple? If they couple, everything will be lost. The photons will be losing their energy. That means here the lattices play a very important role there, and their operational thresholds can be reached at relatively low intensities of laser pumping. So construction, it's not there in your syllabus, but a laser is constructed from three principal axes: energy source, gain medium, and some mirrors from the optical resonator. Let's just have a look into that, because unless we have an idea of how a solid state laser looks like, we are not going to understand many things about this solid state laser. So here is a highly reflective mirror there, and then you have got flash pump source. So this is a source of all your lights there. You can use any material there. Here is a mine, the NDYAG laser. NGYAG laser media. A partially reflective mirror is also there. That means it allows sunlight and it absorbs also. But here it is fully reflective. Here it is partially reflective. That means it is allowing. You can see that the light is passing through that and some light is reflected back also. But here the entire light is reflected back. There is no passing here. Okay. So this is the laser expert. So this optical resonator is there. You are having a flash tube, fully reflective mirror and partially reflective mirror. Inside that you have a ruby laser medium. So let me tell you before that what this NDYAG stands for. This NDYAG stands for garnet, neodymium doped yttrium aluminum garnet. So that is NDM is to Y3Al5O2. Okay, so here is one example where you can see that ruby laser, the first laser one that is still used today, relevant today. It is ruby synthetic aluminum Al2O3 with 0.03 to 0.5 chromium oxide. So you need to remember this. Chromium 3 plus ions and pumping of light. Here it is. How it is constructed is given there. You can just have a look at this and get an idea of that. Solid state lasers. Now here it is given. Yttrium, aluminum, garnet, neodymium, yttrium, aluminum, garnet laser is active indicated is a trivalent neodymium added to an yttrium, aluminum, garnet. So that garnet is given here. Y3Al5O12. Garnet, I think you've seen spinels, right? Spinels and garnets are some elements that are some minerals that are available naturally. Both have the same type of properties. But NDOAG, yeah, I mean, the garnet has got special properties of not absorbing the lattice light. So again, this structure is being repeated here. You have to draw this structure and explain the terms that are being used there in the solid state lasers. What are the advantages? The advantages of is of wasting material in the active medium, because here material is used in the form of solid. Construction of solid lattice is very simple, comparatively simple, and cost of the solid laser is also economical. What are the disadvantages? The output is not very high as in case of the gas laser there, but still CO2 is not very friendly. Efficiency of the solid state laser is less compared to CO2 laser. So you can see that gas we cannot hold, we need separate instruments to hold it, and neodymium and materials you can use. What are the applications? It's solid state lasers are usually used when drilling holes in metal. So that is capable of drilling the holes in the metals. It's a pulse type solid state laser and can be used in medical applications such as endoscopy. So a very highly essential, still used nowadays, and in military application it is used to target destination systems. So that is not very human friendly, but still they are being applied there. So I think we have an idea of all the solid state lasers. I'll stop with this and explain about the mechanism of the solid state laser in my next class. Thank you for joining me.